All right, let's partition. Partition just means divide. All right, we're going to divide a line segment into particular ratios. Okay, so we'll start in the one-dimensional case, kind of like we always do. Okay, so let's take the point 3 and 11. Okay, and let's divide this into a 3-to-1 ratio. Okay, now midpoint, that divides it into a 1-to-1 ratio. Again, this is part to part. So you're going to put something here, and again, visually, we can just put it right there. Okay, it's going to say that this thing is 3 times longer than this thing. It's not necessarily that this is 3 and this is 1. It's 3 times this. 3-to-1 ratio. Again, what's a 3-to-1 ratio? 3-to-1, 6-to-2, 9-to-3, 12-to-4. Any of those things have the same ratio of 3-to-1. 3 of these for every one of those. Again, it's a part-to-part thing. Okay? Now, how long is this from 3 to 11? Well, that distance is 8. Okay? And again, there's so many different ways to think about this. A 3-to-1 ratio, again, is part to part, is the same thing as starting at 3 and going 3/4 of the way across. And again, I'm going to do some dogs and cats here. Okay? Let's say that dogs to cats are in a 3-to-1 ratio. Okay? And let's say I even knew the data that really there were 15 dogs and there were 5 cats. You see how 15 dogs and 5 cats is a 3-to-1 ratio? But how many dogs out of the total were there? Well, there were 15 dogs and the total number of animals were 20 animals. Right? So that means 3/4 of the animals were dogs. 3-to-1, part to part, is the same thing saying 3/4 of the total. So, because if you go 3/4 here, then you're left with 1/4. So take a line segment. If you divide it such that this is 3/4 of the line, well, then you have to leave 1/4 of the line, and then you're guaranteeing yourself that this is 3 times bigger than that. Again, this is just one approach. So just take 3/4 of 8. 3/4 times 8 is 6. So just walk 6 steps over, and you end up at 9. Now let's check our work here. What does that say? How far is it from 3 to 9? Well, that's 6. How far is it from 9 to 11? That's 2. So this guy is 6, and that's 2, and you're like, oh, cool. I found the number that partitioned, meaning divided it, into a 6 and 2, which is a 3-to-1 ratio. Again, this has a lot to handle right away. There are different ways to look at it. We'll do it different here in a second, but they all end up being the same thing. 3-to-1 ratio, 3 parts for every 1 part, is the same thing as going 3/4 this way, or you could go 1/4 that way. Okay, let's draw that same thing in a 1 dimension. Again, I know in the 1-dimensional case you probably just did it in your head, and that's okay. Okay, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so this is another way to do it. A 3-to-1 ratio means take 3 steps this way, 1, 2, 3, and then take 1 step that way, 1. Okay, then take 3 more steps this way, 1, 2, 3, and take 1 step that way. Boom, check it out. 3 steps, 1 step, 3 steps, 1 step. If you keep going 3 for every 1, eventually you're going to meet, at least in the easy cases. And where did you meet? You met at 9, right? 3 steps for every 1 step. 3 steps, 1 step, and that guarantees that this is always 3 times longer than this is because I'm taking the same number of things, but these are always taking 3 steps and that's 1 step. That's another way to think about it. Again, I'm going to think about it in this way. This is me. I'm doing that every single time, and I'm doing it in 1 dimension, I'm doing it in 2 dimensions. If I want a ratio, 3-to-1 ratio, I'm going to go 3/4. I'm just going to find 3/4 of that distance and walk it. Again, let's do another one. Let's say I'm here at 4, and I'm going to go all the way to 19, and I want to divide it into a 3-to-2 ratio. Again, 3 parts for every 2 parts. So I just want to go 3/5 of the way there. So I want to start at 4, and I want to find the point that makes this 3/5, because then that's 2/5, and it's 3-to-2. Okay, so how far is it from 4 to 19? Well, it's 15 total. What's 3/5 of 15? 3/5 times 15. 15 and 5 make a 3. 3 times 3 is 9. You're like, cool, 9. So just walk 9 steps. 9 steps over from 4 is 13. You can check your answer. See how far 13 is. It's 6 from here, and it's 9 from here. Look, 3-to-2. 9 to 6 is a 3-to-2 ratio. 3-to-2 ratio, to me, makes the most sense to look at it as a 3/5 of the way. Or you could have went 2/5 of the way this way. 2/5 of 15 is 6. So go 6 down from 19. It doesn't actually matter which way you started. And again, let's do it in 2 dimensions now. We can do it as slow or as fast as you want. It's not going to matter. You divide this thing, you're partitioning it into a certain ratio. The ratio can be whatever you want it to be. Okay? All right, let's say you're going to do a 2-to-1 ratio. Okay, let's start here at 3, 2, and let's go all the way to 9, 14. Okay, see this line segment? I'm going to divide it into a 2-to-1 ratio. This is point A and this is point B. You got to have a starting point. Otherwise, you don't know if it's this is supposed to be 2 and that's supposed to be 1, or that's supposed to be 2 and that's going to. So a 2-to-1 means my A is going to be the 2. So it's going to be somewhere like there. Visually speaking, a 2-to-1 ratio means that's twice as long as that. And now we need to find that point. This is what I'm going to do every single time. Again, because these things are valuable in other ways. I'm going to go over, and I'm going to go down, and I'm going to put those numbers. Okay, how far over is it? 3 to 9. That's 6 over. Okay? 2 to 14 is 12 up. Okay, so if I'm at A and I walk 6 over and 12 up, I get to B. But I don't want to walk the whole way. I only want to go how far? Well, if I split this into a 2-to-1 ratio, I want to go 2/3 of the way over. Okay, so let's find our x value. 2/3 of 6. Don't take 6 steps. Take 2/3 of those steps. Take 4 steps. My y value. Take 2/3 of 12. 2/3 of 12 is 8. So instead of taking 6 steps over, I want to take 4 steps over. So 1, 2, 3, 4 steps over instead of 6. 4 over from 3 is 7. Don't take 12 steps up, only take 8 steps up. 8 steps up from 2 is 10. And I have my coordinate point. I guarantee then that this distance, whatever it is twice as long as this distance. This was 6 steps, and it'd be left with, that was 4 steps, and I'd be left with 2 steps. 2-to-1. I did 8, and I was left with 4. 8 to 4. It's just the same ratio. To me, this is the key. Just find that number. That tells you what fraction to go across to guarantee you that ratio. We'll do another one. Again, we can do as many of these as you want. There might be other methods. It's fine. This method is the method I think is the easiest. So we'll take 5, -3, and let's go over to How about negative 10 and comma 7? Negative 10, 7. Okay. And let's divide this. Oh, in my head, I think I was going to do a 3:2 ratio. Okay. Let's call this A and this B. Okay. There's the line segment. I don't know why I made that dotted. There's your line segment. And let's find this out. Here, let's find those total numbers. Okay. Negative 10 all the way over to 5. How long is that XY? So that's 15 long there. Okay. 7 all the way down to negative 3. That's down 10. Okay. So a 3:2 ratio. So I'm going to put my point, I don't know, maybe right there about. Start at A, 3:2. Every one of these steps, I got to do 2 of these steps. Okay. So 3:2 is the same thing as 3/5. Okay, that's my fraction. So xy's, my x variable, I'm going to do 3/5 of 15. 3/5 of 15 is 9. My y, I'm going to take 3/5 of 10. 3/5 of 10 is 6. And that's how far I need to walk. Right, that's my walking. Start here. Again, start at point A and walk over 9. Boom, 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 boom. You end up at negative 4. 5. 9 steps this way, you end up at negative 4. I want to take 6 steps up. Negative 3. 6 steps up, I get to 3. And I'm done. That point partitions this line segment into a 3:2 ratio, which is the same thing. Instead of taking all the way, I go 3/5 of the way. 3/5 of the way breaks it into a 3 and a 2. I could have done 2/5 of the way this way. And again, I have to tell you the points A and B so you know whether it's 3 and 2 or 3 and 2. So I got to tell you which one's the starting one and which one's the other one, right? This is always kind of like the first one and then the second one. Okay, want to do another one? And we can do as many as you want. You can see that I'm doing the same thing every time. I'm not saying it's the only way to do it, but it's the way that I like the best, and I would suggest doing that. Don't have to. So how about negative 5, 2, and what's the ratio maybe we haven't even done? What should we do? Maybe a 3:1 ratio? Okay, let's do a 3:1 ratio this time. So let's go over to 7 and up to 10. No. Yeah. 7, 10. Okay, so I want to break that up, and I think I just said in my head 3:1 ratio, which means I'm going to go 3/4 of the way across. This is A, and this is B. So if I want this, it's going to be something like that on my picture. This is 3, and that's 1, right? A 3:1 ratio. So that's approximately what the point is. I mean, I didn't draw these to scale, but it's close. It's close. So let's find these values. How far over do you go? Negative 5 all the way over to an x value of 7 is going 12 over. 2 all the way up to 10 is 8. So I need to find for x, I need to go 3/4 of the way. The whole way was 12. 3/4 of 12 is 9. And my y value, I need to go 3/4 of 8. 3/4 of 8 is 6. Okay, so take 9, start here, and go 9 steps over. You end up at 4. Go 6 steps up, you end up at 8. 4, 8. And I know it doesn't look very good. Well, you know what? 4, 8, it's not bad. It's not bad. I mean, could have been worse. But there's your point. And again, 3:1 means this is 3 times bigger than that guy. So just go 3/4 of the way, which leaves 1/4 of the way left. Hopefully that's enough to see kind of how you would partition these things. There's really not anything else to it. Partitioning them into segments by going a certain distance away. I'm always going to use this fraction, I'm sure you can just count. If you have a coordinate grid, maybe we can look at, now let's stay in this 2-dimension. I know you can just count. So if you look back at this one, you could just take 2 steps this way, 1 step that way, 2 to 1, and then take 2 more steps, and then take 1 step. And you see you'd end up right there at that 7. 1 step for every 2 steps. So 1, 2, 1, 1, 2, 1. And you'd end up at right there, 7. And then on this one, you would take 2 steps up, 1, 2, 1 step down, 2 steps up, 1 step down, 2 steps up, 1 step down. And then you'd be at that same value. You'd have to do that 4 different times, right? 4 2s is 8, 4 1s is 4, and all of a sudden you'd break 12 into 8 steps and 4 steps, which is exactly what we did right here. We took 8 steps up. Again, if it's on a coordinate grid, you can just step this way, step that way, and find the middle. You can step down, and you can step up, and you can find the y value, and then you know the x and the y value. I would only say that this is better because all of the problems worked out now to numbers. And the stepping way works fine if it's on a grid and they're in numbers. This way works even if it's not. Even if this, 2/3 of 11, it still works. 2/3 of 11 is just, 22/3. You could still just go 22/3 up or over from a coordinate point and you could still find it. It wouldn't be an exact coordinate point, but you could still find the numerical value of it using fractions. And again, maybe you guys don't like fractions, but you know what? This is a great review. You should be able to do 2/3 of 6 and 12 and 3/4 of 12 and 8 quickly. So this is 3/5 of 15, 3/5 of 10. This is a great fraction review, if not. Hopefully this helps you partition segments, and you can review this before the test.